Okay, so today we're going to start a new topic on metals and acids. So we're going to get straight into it, but just before we do that, I'm just going to show you some pictures of the kind of metals that we're talking about in the next few lessons. So up here in the top left-hand corner, we've got some processed magnesium. Over here, these are bits of zinc, a nice refined cube of zinc there. And then down here in the bottom left-hand corner, we've got some lead. And then this is the iron that you all know and love. All right, so when we're talking about the metals in the coming lessons, you want to be thinking that these are all they're all shiny, they all conduct electricity, all the normal metal kind of things that you know about. All right, let's get cracking. Okay, in your books, you'll want to give yourself the new title, Metals and Acids. And while you're watching this video, at any point, obviously you can pause it, you can go back, you can watch a little bit of anything you might have missed or you want to watch twice. And then at certain points I'm going to tell you to stop, copy something into your book, so you should pause the video, or I might tell you to do some questions, so pause the video, do the questions, and then carry on. And it only really works if you actually do pause the video and do the questions. Okay, so the pictures of the metals I just showed you, you could see that they all had similar properties, they all looked shiny, they all conduct electricity, so they're all very similar. They also react in similar ways. So if I take one metal, magnesium, and I react it with an acid, hydrochloric acid, I get this reaction. So I produce this new compound, magnesium chloride, and I make hydrogen gas. Now, because metals are all very similar, they all do this same reaction. Okay, so just so we're clear on what's happening here, we're taking magnesium, which is a solid metal, and we're reacting it with hydrochloric acid. So in terms of particles, that would look like this. So we have our solid metal. So you can remember that in a solid, particles are all arranged regularly and they're packed close together. And then we're reacting it with hydrochloric acid, which is actually, it's not a liquid. I mean, it is a liquid, but we don't call it a liquid. We actually call it an aqueous solution. Aqueous solution. So what does that mean? That means that it's aqueous means water, and solution is it's dissolved in something. So aqueous solution just means that it's dissolved in water. And what does that mean? It means that you can see here I've got a liquid in a test tube. So these are my liquid particles. Now because I've got it dissolved in water, it means that some of these liquid particles, some of them that I'm shading now, will be your acid. Okay, so these would be your acid particles. And then the other ones, these would be your water particles. Okay, so in this reaction I take my solid magnesium metal and I put it into my aqueous solution of hydrochloric acid. And I make magnesium chloride, which is also made as an aqueous solution. And I make hydrogen gas. So if we were to do this reaction, what we would see is we would see a solid piece of metal going into a clear solution. Then the metal would slowly disappear. There's no solids over here. So the metal would slowly disappear as it forms this new aqueous solution. And you would see bubbles of gas being produced. And if you look closely above the test tube, you'd be able to see something that looked a little bit like smoke or steam, but is actually hydrogen gas. Okay, now what I'd like you to do is pause the video here and copy that down into your book. Okay, so now that you've got that in your book, we're going to carry on. Like I said before, metals will all do a similar reaction. So if they are able to react with the acid, they will produce similar products. Okay, so let's just look at two other examples. So I've got here zinc metal plus hydrochloric acid. Now that's going to make me zinc chloride and hydrogen as a gas. Okay, so you can see that it's the same again. I get the first part of this compound is the metal, zinc, and the second part, you can see the chloride comes from the acid here. Hydrochloric acid gives me the chloride. Okay, so we can actually work backwards as well in this one here. So if I make iron chloride, then my metal must have been iron. And I've made a chloride, which means I must have been using hydrochloric acid. And you can see that from these three reactions that we've done, so if I just number them, this was our third reaction, this was our second reaction, and the one right at the start of the lesson up here we had number 1. We can see that they all follow the same pattern. Metal plus acid gives us a new compound plus hydrogen gas. Okay, so we can say here that we have metal plus acid gives us, now this thing here, I'm going to call this a salt, plus hydrogen. Okay, so these are all salts, all these compounds that I've made, magnesium chloride and zinc chloride and iron chloride, these are all known as salts, where it's a metal and a non-metal. Okay, right, so what we've done so far, actually before we go on, it's best if you pause now and just copy those down into your book so you've got 2 more examples. Right, so here we've used the same acid every time, hydrochloric acid. Now there are more types of acid. Okay, there are 3 types of acid that we're going to talk about. Okay, the first one, which we've already met, is hydrochloric acid, and that makes chlorides. Zinc chloride, iron chloride, magnesium chloride. The second type of acid is called nitric acid. Now that makes compounds or salts called nitrates. For example, you might something like zinc nitrate. And the third type of acid is sulfuric acid, which makes compounds or salts called sulfates. Okay, perhaps like iron sulfate. Okay, so you need to know these 3 acids and the compounds, the salts that they make. Alright, so you'll need to make a copy of that table in your book. Okay, now that you've got that table in your book, here are 4 questions for you to do. So for each one I've given you part of the reaction and you need to fill in the rest of the reaction. So pause it now, copy those 4 into your book and fill in the blanks. Okay, so you should have got iron plus nitric acid would give you iron nitrate plus hydrogen. Remember that's going to bubble off as gas. If I make zinc sulfate, I must have started with, so the first part is my metal, so I must have started with zinc, and it's sulfate, so if I look up here, which acid gives me a sulfate? It's the sulfuric acid. So I would have had sulfuric acid. Okay, so if I make magnesium sulfate, well, the metal was magnesium, and it's sulfate again, so it'll be sulfuric acid. And hopefully you all remembered that these reactions are all the same, so you should have had hydrogen gas over here as well. And finally, iron, should be getting the hang of this now, iron plus nitric acid would give you iron nitrate plus hydrogen. Okay, so when we do these reactions, how can we be sure that the gas given off is hydrogen gas. You might see some smoky looking stuff coming out the top of the test tube, but how do you know that it really is hydrogen gas? Well, there is a test for hydrogen gas, and that test looks a little bit like this. So if I have a test tube here that I think has got hydrogen gas in it, I think it's got hydrogen gas, but I'm not sure. What I can do is I can take a lit splint and I can move the lit splint. So what I mean, the lit splint is the those thin wooden strips that you can use for like Bunsen burners. What you can do is you can set one on fire, okay, and you bring it close to the top of the test tube here. Now, if the test tube does contain hydrogen gas, you will hear a pop sound. Okay, if it doesn't contain hydrogen gas, you won't hear that pop, because when the lit splint comes over here, the hydrogen gas burns, it burns really quickly, and it makes a pop sound when it does that. So if you hear the pop sound, you know you've got hydrogen gas. Okay, so that's it. But before we stop, there are a few things here that you need to know for future reference. So number one is you might want to get yourself a flashcard, because there's quite a few of these reactions coming up in this topic and you need to know them all. So today's reaction that we've learned about was metal plus acid would give you, and then on the reverse you can write salt plus hydrogen. Okay, and you can do different things if you want to. So if you wanted to, on here you could add in an example. So you could say, for example, zinc plus sulfuric acid, and then you can fill in the rest on the back yourself. So there are going to be more reactions to learn about, so it might be a good idea to make one for that. The second thing you'll want to make a flashcard for is your different acids. Okay, so if I have hydrochloric, makes, and we have nitric acid, makes, and sulfuric acid, makes. And then on the reverse side of this flashcard, you would put obviously chlorides, nitrates, and sulfates. And the final flashcard you're going to want to make is your test for hydrogen gas. And on this side you'll want to describe that, so it will be place lit splint near test tube of gas, and if it is hydrogen, it will make a pop sound. Alright, and then you use those to test yourself. Excellent.